Okay, and welcome to week 3. And today we're going to have a presentation about something that is kind of fundamental to video production. And I believe we've touched on it before, but I want to make sure that we have all the important facts covered. And that is the waveform monitor and how to use it, video scopes and levels. Now you're going to see these all over the place on your editing screen, but it's important that we understand what they do. And so we're going to cover the fundamentals real quick. Okay, so scopes and color correction. They kind of go hand in hand, and before we can understand those, we have to understand something about the video signal. And it's sometimes called the waveform, the video waveform. Now, video is like a complicated wave going across the sea, whatever you want to call it. Just like any other sine wave or electronic signal, it has all kinds of little nuances. And this was created a long time ago, back in the 1930s. Now, the video signal itself is calibrated in units called IREs, Institute of Radio Engineers. And you don't have to remember that necessarily exactly how that came to be, but you understand. This is an old gift here. If you are in a job where someone is trying to assess your capabilities, if you know that it's calibrated in IREs and they ask you what it's calibrated in, and you can answer that, they're going to think you're pretty smart. And here's another one. The waveform monitor screen is called the graticule. And I didn't spell that because I'm not even sure how it is spelled, but if you know the word graticule, you're going to be considered a genius. Actually, some of the people you work for probably won't know it either, so it doesn't matter. Okay. The point is that every part of the video signal can be seen on the waveform monitor. And that is rather important because as you diagnose the video signal, you're going to look at different parts of it. Now, some of this is no longer necessary. This existed way back when the video was analog. There are some things that only engineers would really work with, and the average video professional wouldn't have to know, but occasionally it does come up. You will need to know less of it than I did. Okay, most of these readings still apply. Now, when I say that, it sounds contradictory, but it actually isn't, meaning that the reason why the video signal has to cap off at a certain point and has to go below a certain point, the original reasons may have been different, but it is still considered best practice to follow these rules. Even though the reasons may have changed, you still cannot violate these rules. That's because they're rather important. Okay, and some of the problems that used to exist no longer matter. And you'll understand what I mean as we go along. Okay, here it is. These are what waveform monitors used to look like. This is the old school. I actually carried these into the field. In fact, some people carry 2 of them because we're going to mention the vector scope, but we don't actually have one. And that is to say that we don't use it quite as often. It isn't quite as important. The waveform is more important. But the fact of the matter is that the waveform monitor and the vector scope typically go together. You have all the screens you can ever possibly imagine available to you on your editing programs, but the very minimum that a person would carry with them into the field besides their picture monitor was a waveform monitor. These were heavy. The scopes were carried in the field to monitor quality. Today they are all digital, and they're built into the cameras. You can see them in your camera viewfinder, and they're available on your editing screen, as you already know. Now, let's talk about the video signal for a minute. Now, you're going to see a waveform monitor down here, right below me. And you can see, I'm going to lose you here, my pointer. You can see this is what that waveform monitor is looking at. This is color bars. This is a signal that is generated by the camera for calibration purposes. Now, this little white stripe here is known as the 80% bar. Now that is right there. That's how the waveform monitor is reading that bar. Now this white here is a little brighter. This is called the 100% bar. And that shows up here. Now these thicker lines, those are areas where color is involved. And they kind of overlap. And so it makes it a little bit more confusing, but this is typically how the image would look. And some of this you don't have to know about. This is called the color burst. That is called the sync tip. They have all kinds of crazy terms like front porch, back porch. We won't go into all of those. But one other one you should recognize is It's hard to see down here, but these little lines here, this is true black, or TV black it's called, shows up at 7.5. A little bitty line there. There's a line right above that which is a little bit lighter than black, and a line a little bit below that which is lower than black. And yeah, you can get lower than black if you understand TV black. Now let me explain this really quick. TV black exists because there was a time when if you went below a certain level, the television would simply not recognize it. When you go to watch TV, you would see weird things happen, like distortion, or it simply wouldn't be visible at all. Or somehow the signal with the set couldn't recognize it, and so it caused all kinds of crazy issues. And so therefore, they said all black must be around this line so that every television can understand it. And that was back when TVs were very different than they are today. Now in Europe, by the time they got to Europe, they fixed that problem, and so this little checkered line here was 0, and that's where black started in Europe. And so up until recently, America really had to worry about this. Now, not so much. So in television, we finally have the option of using 0 as our baseline, but most people still use that 7.5 out of convention. So that's still the best way to go in America, 7.5 as TV black. Okay, everything else is somewhere in the middle. And to understand the signal, you have to understand where things are. There is a limit to how bright the signal can be. If you get over 100%, that's not good. In fact, today, most cameras will cap off at a certain point. Really, maybe you can get up here, but you can't go beyond that. They'll just ignore anything beyond that. And then you'll lose that information. Just like, yeah, you can go below 7.5, but if you start going below 0, then that information is going to be iffy. Now, the odd thing is, if you do go below 0, it's possible to get it back. Whereas if you go above 110, let's say, that information may be lost forever. And just as I say, there's a limit to how dark the signal can be. Everything else must be in between. These are all your grays, all your colors. And the waveform monitor doesn't really care about colors. It cares about tonal values. And so we can interpret these colors differently. And this is called active video. Now, if there's a flat line here, that's no video at all. And if there is simply a black line at 7.5, that would be a blank screen. What is all this for? Well, it's to diagnose problems. Basically, if you've got a video program, or if you're shooting a video program, and something is wrong, you should be able to spot why it's wrong by looking at the scope. If something is overexposed, the scope will tell you. If something is underexposed, the scope will tell you. And you're keeping video within acceptable parameters, meaning that let's say you think there's a problem. The scope will tell you for sure. Is this overexposed? Well, it's not over 100, then it's not overexposed. Maybe your viewfinder is wrong, because you always have to have some kind of a check, and the waveform is the best way to go. And also, let's say you're looking at a picture of something, and you're wondering, where if it's like, say someone's wearing a gray shirt, you're wondering, where that is in terms of the lighting. You can see it on the scope. You can see usually where every aspect of the picture is, and we'll talk about that in a minute. Okay, here we are in Premiere, and I have loaded up. I've moved the program monitor down a little bit to show you the scopes. Now, you should have these scopes on your workspace in the lab, or they should come with your program, and they're called Luminetti scopes or whatever they are. If you don't have them, they're here under the window somewhere. I highly suggest that you use them. And so we're going to diagnose this video. And what I'm going to do is we're not going to use the whole timeline, because this is going to be a simple understanding. Now this is a shot. Now notice as I move to the timeline, I can see the video. Now I chose this shot because there are problems with it. Now if you look up at the scope here, you can see that everything is a little bit bright. I would say if you look at the image, we're losing just a little bit of detail. I think there's more detail there that we're losing. And so I'm going to show you how you can diagnose this and get it back. And for now, I'm going to remove my face here. There we go, just to make it a little easier. And I'm going to, and this is video only, there's no audio associated with this. And if I go to Video Effects over here, I'm going to go to Brightness and Contrast. I'm going to go to Color Correction, and I'm just going to grab Brightness and Contrast, because that's almost all you need. Brightness and Contrast. We'll do Color Correction another day. This will be a short one. So once I put Brightness and Contrast on there, then I can look over here, and I can see, there it is, and this is an effect. Now remember, you can use the little stopwatch there to mess around with that if you want to. But in this case, I wouldn't necessarily think that would help you. But I wanted to show you how these work. Now start with brightness. As I move brightness up, now watch the scope here. As I move the brightness up, you see that the entire waveform goes up and down. And so you can also see that it darkens things a bit. Now, the original shot might have been a little overexposed. You might have lost a little detail. Now, let's say we really overexpose it. You can see detail disappears. So, a perfect shot, now notice, look down here for a minute. I'll just expand that a little bit. See if I can see that. You can see the sidewalk and you can see the street. If I expand the brightness, there's a point where we lose the difference between the sidewalk and the street. That is clipping the whites. That information is being lost. The computer's throwing it out. So, if I want my video exposed properly, I want to make sure that I can see the difference between the sidewalk and the street. I want those details. Now, there are other situations that come up as well when the video is too low. That is called crushing the blacks, when you lose detail in the shadows. It's the same principle. Now, right now, I will say that overall, this is a healthy waveform. If I were to move my contrast, look what the contrast does. If I bring the contrast all the way down, the entire video crushes into a single line, which is gray. And if I bring the contrast up higher, it kind of goes off in both directions and we lose most of the detail. I don't even know how to interpret that, to be honest with you. But the point is, let's say your waveform looks something like this. It's a little bit too much contrast and you're going up and down. Let's say it's really overexposed. It could be your detail is way up there somewhere, and in order to bring it down, you have to lose detail. And so there you may need to lower the contrast just to get the waveform so that you can center it. Meaning that you want to get your blacks around the 7.5 mark, which is down here, and you want to get your whites up here towards 100, or at least up around 80. And so the idea is that you move your contrast so that you can center the shot, and then you kind of work it into that scope. And that's what you should do with every shot. Okay, now this shot is obviously much darker. This is a shot of a dark room. It's the control room. And you can see that we have our student here. And this is all that is left of our student. Most of the video is way down here. So I'm going to go ahead and apply brightness and contrast to there as well. And when I do that, I get access to this. And you notice if I bring the level up, I can artificially create grays. You can see where that video becomes more visible only because we're turning black into gray. And in order to do that, if I wanted to get wanted to overexpose elements of this, I would literally have to do that. Now that would not be the way to do this. In fact, as long as this is not below the 0 mark, it's technically acceptable, but I might want to get some more oomph out of it. So let's say I bring it up that much. So now I'm putting the black above the 10% line, and I can raise the contrast of the video to compensate. And so I can move this around. So let's say black is now around 7.5. My upper level video is around 80% or 90%, and that's okay. And so that may be an acceptable shot. And so in doing so, I'm getting information out of those shadows. It's hard to see in this context, but it is possible. Now, one other thing I wanted to cover real quick is the vector scope. The vector scope measures color. Now this does too, but it doesn't do it as well. It's more confusing to use it this way. Color is measured from the center of the wheel, outward. These little boxes that appear on the vector scope are the outer edges of where acceptable color normally is. So, if I were to go back over here and put in color balance, hue, and saturation, and I were to drop that into there, and find it down here, hue and saturation, I don't want to mess with hue. Let me show you what happens if you mess with hue. If I were to turn the hue, the entire wheel rotates. Don't do that, because that makes an awful mess. It messes up everything. On the other hand, saturation can be useful. If I oversaturate the video, you'll see the colors become gaudy. I don't know what the term you'd use, but overemphasized. If I bring them down all the way, they go into 0. So it could be that I want to add a little bit of extra color. It could be that the color looks a little bit unnatural, so I bring it down some. That is what you can do. And so if I were to go back to this shot here, and I were to apply my color saturation there, and if I were to go to saturation, see what I can do with this. You can see if I bring the saturation up, the red and the bricks are showing up. If I bring it down, basically it's all going into a dot. And so the best rule of thumb I can give you is do not bring those colors out any further than that. And here we are looking at a still image of color bars. And you can see this is how the waveform monitor should be interpreted. As you can see, this is where the scope is trying to interpret it correctly. The image may be oversaturated, but this would be an opportunity to demonstrate how we can fix that. If I bring my color balance in here, I can calibrate it by removing saturation from the image. I bring those down so that they are within the little boxes. That helps a little bit. It could be that there's something else wrong with this particular scope because I just grabbed that off the internet. If I were to put hue, if I were to put brightness and contrast in there as well. Okay, and I'm going to diagnose the problem with this image. You see, we have what was 100% bars, which appear to have been clipped. This was overexposed at some point. This is our 3 levels of black, which we described earlier, which are now parked at around 7.5. But I can't seem to get the 100% bar at 100%, so right now it is 80%. So the image isn't quite perfect, but it'll do for our purposes. And so there, if we were to bring up our saturation just a little, we can get those in their appropriate boxes. And so we can see where, this is where I believe your yellow is, and so forth. And that will be enough today in terms of our discussion of the scopes and how to use them. But the important thing is they're a reference and you have to understand how they work.